In the upper atmosphere, we have the conversion of nitrogen-14, stable nitrogen, into carbon-14, which is an unstable isotope of carbon. That carbon circulates through the atmosphere, and in carbon dioxide for the most part, is taken in by organisms. And organisms at the Earth's surface, when they take in carbon, they're taking in the normal form of carbon, the stable form, which is carbon-12. They're also taking in carbon-14. And they're also taking in another isotope, carbon-13, which is relatively stable too. So what we do in archaeology or in paleontology, when we get a radiocarbon date, what we're trying to do is to convert the amount of carbon-14 that we can measure in the sample into a date. Well, what's going on here? The carbon-14 is unstable. It's a radioactive isotope, and over time it decays back through beta emission. It changes back to nitrogen-14, and it's lost. To compute a radiocarbon date, then, we have to look at the amount of carbon-14 that's present and compare it to the amount of carbon-12 and carbon-13 that are present in the sample. And the ratio that we determine gives us an idea of how long it's taken for this ancient sample to change from the state that it had when it was alive. We take in carbon-14, of course, during life. We're always taking in carbon-14, so we maintain a fairly constant level of it in our body. As soon as we die, the carbon-14 starts to decay. So the ratio between the carbon-12, 13, and the carbon-14 is going to change. That's the basis for our dating. So that's an absolute dating technique.